Hello guys, good day. So this is supplemental video to module 1. So as per discussion with the engineer Jimena, diniscuss niya yung mga concepts and also discussed it to the sa modules yung mga concept. However, beyond that concept, we need to know the computation or uh, what will be the effect when it comes to numbers yung mga aircraft loading na yun, like pressurization, no? Wing loading, landing gear loading, and etc. So this PowerPoint or PDF is aircraft load. So it's all about aircraft loads. So as you can see, meron ka dyan BN diagram, no? Or the airspeed versus load factor diagram. So, nandyan yung structural limit ng isang eroplano or tinatawag nating flight envelope. So, yung flight envelope na yan or the BN diagram represents the structural capability of your aircraft habang lumilipad ka at certain load factor versus to your airspeed. So, as you can see there, meron dyan BS, no? Ano yung ibig sabihin ng BS na yan is the stalling speed of the aircraft. A, VA is the maneuvering speed, BC is the cruising speed of your aircraft, and DD is the diving speed. So yung N na yan is what we call the load factor. So technically from your subsonic aerodynamics and aerodynamics, simply when it comes to straight level flight, the load factor is equal to 1. However, if you are climbing, that is changing. If you are inverted flight, you have negative load factor. If you are maneuvering, no, you have different load factor. And different aircraft has their different load factor limit. Okay, so let's first discuss what is a aircraft loads. So as discussed, as you can see dito sa screen ninyo, no? Aircraft loads are those forces and loadings applied to the airplane structural components to establish the strength level of the complete airplane. Okay? The determination of design loads involve a study of the air pressure, inertia, during certain prescribed maneuvers, either in the air or on the ground. And aircraft loads is the science of determining the loads that an aircraft structures must be designed to withstand. A large part of the forces that make up design loads are the forces resulting from the flow of air above about the airplane surfaces. The same forces that enable flight and control of the aircraft. So loads, when it comes to loading, no, we have external loads and internal loads. Internal loads meaning the strength of materials of your aircraft structures. Aircraft loads came from different types of loading. The maneuver loads, dynamic loads, ground handling loads, and other loads. So from that loads, ang kailangan nating i-consider is the aircraft geometry, aerodynamic data, weight data and design speed, the stiffness data of the material, miscellaneous system data, operation data, and the BN or the VG diagram. So aircraft loads or the aircraft external loads are generally defined as those forces and loads applied to the structural components to establish the strength of the incomplete aircraft. So inulit ko lang siya, no? And the strength level of structural criteria is defined by the aircraft speed, load factors, maneuvers the aircraft must be capable of performing. So airplane loads come from diverse sources. This include from the FAR subpart 23 when it comes to normal category, 25 for commercial category, and subpart, no, specific from that subpart is subpart C for FAR 23 subpart C, that is structures. So That is the minimum standards na sinusunod ng isang structural engineer. So nandoon yung, as you can see, the component and payload weight, no? Dito we will solve the CG equation or sa CG diagram or the center of gravity equation using table. The air loads, lift, drag, and gas from your aerodynamics. Specific, no, merong VN diagram for the gas loading. And then acoustic loads, thermal loads, landing loads, touchdown by or by arresting, takeoff loads, runway taxi, catapult assisted, takeoff, etc. Power plant loads, thrust from the engine torque, and the gyroscopic effects. Special loads is from towing, refueling, pressurization, cargo, weapons, recoil, bomb release, and blast effects. And most of the loads resisted by the structural elements are due to the aircraft weight and the fact that the airplane accelerates during flight. When it comes to airplane accelerates during flight, we will consider the inertia, no? Inertia loads. From the inertia, no, we know that Newton's second law is acceleration is equal to force over mass, or F is equal to ma. That is your second law. Pero how we define the inertia? Inertia loads, no, as you can read, are primary source of loads for aircraft and arise because of acceleration created by engine thrust, maneuvers, or gas condition. Then the concept, the load factor or G-force, no, kaya siya tinawag na BN diagram, VG diagram. So load factor when it comes in terms of G is used to describe inertial loads created by the acceleration and resisted by the structural components to keep it acting as a unit. Or to make it simple, kailangan when it comes to flying, may nagka-counteract dun sa inertia force. So how do we compute inertia loads? So by written, no, by the written ng Newton's second law, which is F is equal to ma, we compute the airplane accelerations once we know the airplane mass and the net force. Okay? We include all external forces and gravity acting on the airplane in our calculation of F. So this calculation allow us to compute vehicle trajections, no, trajectories, but structural analysis must compute forces inside the accelerating airplane structure in a non-inertial reference system. So again, no, we are talking dito on external forces only acting on the aircraft, not the internal forces or inside forces acting dun sa airplane structures. So computing inertia forces is simple. No, we just write the dynamic equation F is equal to ma so that we compute the acceleration F over m. We can also write the equation as F minus ma is equal to 0. So this will be your dynamic equilibrium equation. Okay? So unwritten that way, which is F minus ma is equal to 0, this equation looks like a static equilibrium equation. So it's called the dynamic equilibrium equation. The term negative ma is called the inertia force. Inertia force are also called by the Alembert forces to honor the French mathematician Jean-Le D'Alembert, now who first formulated the concept and the process of converting the mass, times the acceleration of an object into a static load is called the Alambert's principle. So an alternative way of calculating the vehicle inertial loads is to use the load factor concept. Inertial forces have many special properties. They are vectors that act through the object center of mass, vectors that have a direction opposite to the direction of acceleration, and proportional to the mass of the object. So that is your inertial forces. Okay? So before we go to the inertial loads using the load factor concept, we try to compute this sample problem. Okay? So write the given. Okay. So given the aircraft shown as a gross weight of 15,000 pounds. So that is your weight. Given weight 15,000 pounds. And is being launched from an aircraft carrier. The tension T in the cable acts through the airplane CG as you can see dun sa picture. In the and is sufficient to give the aircraft forward acceleration. So that is A sub X of 3.25 G. We want to find the cable tension. So that is the required. Required is tension, the reaction loads on the aircraft landing gear R1 and the R2. And note the force R1 represent the combined reaction force for both of the main gears. So we will only consider when it comes to 2D or two-dimensional diagram. So first thing first is we draw a simple free body diagram that will look like or kung saan mas masisimplify natin yung ating figure. Okay? So here, we just write X and Y, no, Cartesian plane. So first is meron tayong weight. That is 15,000 pounds. So saan nag-act yung weight through the CG as you can see. So this is no your CG. And sabi nag-act yung cable or tension sa CG. So this is your tension. Ilan degrees? 20 degrees as you can see. So if this is the ground, this is 20 degrees. Okay? And then we have R2, the nose gear here, R2. And then lagyan din natin dito ng R1. Okay? And then the distance. So CG to R1 is 20 inches. So this is 20 inches as you can see sa figure. So if R1 to R2 is 90, therefore this is 70 inches. So from the ground to the CG, as you can see, that is 65 degrees. 65 inches. So this is 65 inches. No? From the ground. And then, ano pa? So simply, the inertia. No, sabi dito, inertia, no, they are vectors that act through the object center of mass. So definitely ilalagay natin siya dun sa CG. Next is have a direction opposite to the direction of acceleration. So if this is the nose of the aircraft, no, if you are taking off. So inertia would be the opposite direction. So this is the opposite direction. This is your inertia. Okay? And then inertia force is what proportional to the mass of the object. So that is MAX. MA sub X. No? So we have a 3.25 G and the weight of 15,000 pounds. So that is your simple free body diagram. So next thing we do is we solve the the value of tension R1, R2, no, as required by the problem. Okay? So first is anong value ng ating MAX or the inertia? Okay? So MAX is equal to F. Yan yung kina-counteract niya, no? F is equal to MA MA, no? So M is equal to W over G. Okay, saan galing yan? Simply galing lang dito yan. So given yung weight, no? That is your force, M, and the gravitational acceleration. So kung titingnan natin, MAX is equal to the A sub X, which is 3.25 G, times the value of M, W over G, no? So this is your A sub X, and W over G is the M. So MAX. Okay. So maka-cancel out yung G. MAX MAX is equal to 3.25 W. So meron tayong W. MAX is, okay, so we solve the 3.225 times the weight, which is 15,000. Okay. So our MAX or the inertia force is 48,750 pounds. Okay. Okay, let me share my screen again. Okay, so again, 48,750 ang nakuha natin sa ating calculator for the inertia force. Next is, gagamitin na natin yung ating free body diagram. There are three forces unknowns in the problem: the cable tension, the reactions R1 and R2, and we need three equation by writing the summation forces, including the inertia forces in the x direction and the y direction. So we start in the x directions or in the horizontal directions. Summation forces x is equal to 0. Going right is positive. So we have the negative T, no, the cable tension, and that is cosine 20 degrees plus the MAX is equal to 0. Okay? So, transposition ng ating T. So, T is equal to MA sub X over cosine 20. And that is 48,750 pounds over cosine 20. No? And that will result to, okay? So meron tayo ditong yung answer over cosine 20. So that is 5,1. Cable tension T is 51878.66641 pounds. Store A. Okay? Ship store A. Okay? Okay, so let me share my screen again at Good Notes. Okay, so next, next is getting the value of R1 and R2, no? So paano natin kukunin ang value ng R1 and the R2? So using the forces, no, summation forces in the y direction or at vertical direction. So summation forces y is equal to 0. Going up is positive. So we have R1, positive R1 plus R2 minus W and minus T sine 20 degrees is equal to 0. So from this equation, no, we know na dalawa yung unknown. So kailangan natin maghanap ng another equation to substitute these equations, no, into one unknown. So paano natin gagawin yon? So we need to summation moment CG is equal to 0 clockwise positive. Okay? So pag kung saan tayo nag-moment, technically lahat ng force acting on that will be 0. No? Kasi there is no perpendicular directions. So here we have R1, which is 20, R1 times 20 inch, correct? And then negative plus R2, 70 inch is equal to 0. And then R1 is equal to R2, 70 over 20. Inch is cancel out. Correct? So yung R1 is isa-substitute natin sa summation forces Y. So that is R2, 7 over 2 plus R2 minus 15,000 pounds minus store A sine 20 pounds is equal to 0. Okay? R2 is 7 over 2 plus 1 is equal to 15,000 pounds minus store A sine 20 pounds. Then solving by that, divide both sides by 7 over 2 plus 1 So this is cancel out. R2 will result to a value of, okay? So from the previous equation, we have 15,000 plus 15,000 plus store A times sine 20 over 7 over 2 plus 1. So ang sagot is R2 is 7276.344205 pounds store B. Okay? Next, R1. No? So if you can remember, R2, R1 is equal to R2 times 70 over 20. So that is times 7 over 20. And R1 is 25,467.20472 pounds. Okay. Okay, going back to the PowerPoint or PDF presentation. Yan, sinulat ko na, no? Pero kanina sinolve natin. Okay, so I hope it's clear when it comes to solving the inertia forces. No, kailangan nyo lang tandaan these three parameters, three vectors parameters. Act through the center of mass or through the CG. Direction opposite to the direction of acceleration and proportional to the mass of the object. Okay, so next is after the inertial loads, we have the design loads. No, determination of design loads on the various structural components involved. Study of the air pressure inertia forces during prescribed maneuvers, either in the air or the ground, to ensure the safety and structural integrity and reliability of the flight vehicles, along with the optimality of design. Government agency, both civil and military, have established definite specification and requirements in regard to the magnitude of loads to be used in structural design or various flight vehicles. Terms are defined below, which are generally used in the specification of loads on flight vehicles. So we have the limit loads used by the civil agency, and applied loads used by the military agency are the maximum anticipated loads in the entire service lifespan of the flight vehicle. Okay? So, limit loads for civil agency and applied loads for military is the maximum anticipated loads in the entire service lifespan of the flight vehicle. Ultimate loads is commonly called as or referred as design loads. No? So pag sinabing design loads, that is the ultimate loads of the aircraft. Ano ibig sabihin ng design load or ultimate loads? It is the limit loads multiplied by the factor of safety. So yung maximum anticipated loads, minultiply mo siya sa factor of safety, that is the ultimate load or the design load. What is the factor of safety? Factor of safety is simply ultimate load over design load. Rearranging this equation, meron kang ultimate load, limit load, times the factor of safety. Factor of safety varies from 1.25 for missile structures to 1.5 for aircraft structures, is used in practically every design because of uncertainties involved. Pero however, different component, different uh, factor of safety. Pero when it comes to aircraft vehicle, it will range only 1.25 to 1.5. So FAR Part 23 states that every structures must comply to the maximum 1.5 factor of safety. So ano ba yung mga uncertainties na yon, no? It involves simplifying assumption used in theoretical analysis, the variation in material properties and the standards of quality control, and the emergency action which might have to be taken by the pilot in resulting in loads to the vehicle larger than the specified limit load. So if you are designing, kailangan mong i-take into consideration yung material to be used. Kaya when it comes to design, ang binibigay limit loads. Pero dun sa computation mo as structural engineer, capable yung material up to 1 times 1.5 of the limit load. So that is your ultimate load. Load factors, again, load factors, is another way to calculate the inertial loads. Load factors in normal straight level flight, the wing lip support the weight of the airplane, and load factor is equal to 1 or only 1G. F and only F, lift is equal to weight, or lift over weight is equal to 1. During maneuvers of flight through turbulent gusty air, additional loads are imposed, which will increase or decrease the net loads of the airplane structures. The amount of additional loads depend on the severity of the maneuvers or the turbulence, and its magnitude is measured in terms of load factors. Load factor is multiplying factor which defines a load in terms of weight. Okay, so in terms of weight, so we can write this one, from this equation, load factor, lift over weight. So using that one, from this equation will result to this equation naman. Kasi as you can see, kung titingnan lang natin to, we can cancel out the W. So this is N is equal to 1 plus A over G. A over G. And will result to this equation. So equating the lift and W to the sum of the weight and inertia forces will result to load factor equation. Thrust load factor is obtained from the equilibrium of the horizontal forces as shown in figure. So when it comes to straight level flight, we have also the thrust load factor equivalent to this equation, T minus D over W. If you can remember, this is from your subsonic. Okay? So that's it. Lagi lang natin titingnan. There is a acceleration in horizontal. There is also acceleration in vertical. So we have here another sample problem before we go to the subpart C of the FAR part 20. So as shown in figure, below weighs 120,000 pounds. During touchdown, its engine applies a reverse thrust of 8,000 pounds, and the rear wheels exert 30% of their normal force during braking. And then we have the free body diagram. Find the vertical reactions at nose and main landing gear. So we have R1 or R2 onto this one. Acceleration in the X direction, that is A sub X. And load factors in vertical and longitudinal directions. So that is NX and NC. Okay. So first we draw the given. We write the given. So given is aircraft weighs 120 pounds. Another one is during touchdown, it applies a reverse thrust of 8,000. Reverse thrust, RT na lang. Okay, reverse thrust is 8,000 pounds. And no braking force, normal force during braking. So that is braking force. Exert 30% of their normal force. Braking force is 30%. Okay. Next thing we do is draw a simple or much simpler diagram, no, to solve this problem. Okay. So meron tayong longitudinal directions and vertical direction NX and NZ. Or kung gusto nyo, it's NY, no? Kung bakit ko siya nasabing NC kasi nagsabi ng longitudinal directions. So if you remember the directions of aircraft, vertical, the longitudinal, and the uh, lateral. So kaya nasabi ko may NX and NC. Ito, this one is your NC, C direction. This one is X direction, and this one is your Y direction when it comes to three-dimensional. So, di ba, pag aircraft, nose to tail, X direction. So, that is your longitudinal. Wingtip to wingtip, that is Y direction, lateral. And nose to, or yung height of the aircraft is C. So, kung titingnan natin dito, this is the C direction. C direction, and nose to tail is your X direction. That is the longitudinal direction. Okay? So, okay, malito kung nagamit ko kanina XY, na wala nakakalito doon, kailangan lang ma-adapt natin yung ganong solving when it comes to three-dimensionals and two-dimensionals. So, even though dito gagamitin natin is two-dimensional. So, again, back tayo, kailangan natin i-drawing yung match simple diagram. So, again, we have what? CG. So, drawing tayong CG. So, CG acts yung, syempre, the Cartesian plane. We draw Cartesian plane. Okay. Sa CG, nag-act yung ating weight, 120 pounds. 120 pounds. 120k pounds. Ayan. Next is the reverse thrust. Tama? O kung nag-apply ka ng thrust, so, ayan, that is 4 feet. This one, as you can see, 4 feet from the CG. So, lagay na lang natin dito. Okay. So, this is your reverse thrust, RT. That is 4 feet, no, from the CG. Okay. Next is the R1. So, R1 is 70 feet from R2. So, we draw R2 muna. That is 14 feet. As you can see, 14 feet from the CG. Okay. So, dito na lang natin lagay. So, this is R2 and 14 feet siya from the CG. So, this is R1 is what? 70. So, technically, 70, no, minus 14. So, that is 56. 56 feet, no, from the CG. Ano pang kulang? Kulang is, no, meron tayong binigay na 13 feet. So, para sa yung 13 feet na yan? Dito nag-a-apply yung braking force. Tama? So dahil pa-landing siya and touchdown, no? And then ito yung nose, simply yung arrow ng braking force mo is same with the arrow ng tama, reverse thrust. So we apply dito. This is your braking force na equal to 0.3 R2, no? So sir, bakit R2? Now, as you can see, braking force, the rear wheels exert 30% of their normal force. Ano yung normal force niya? Equal dun sa R2. Okay? So that is 0.3 R2. And lastly, no, ang kailangan mo is the correct MAX or the inertia force. Okay? So in the X direction, we will compute MAX, the R2, and R1. So you need to analyze no paano i-compute yung ating mga unknown, which is vertical reaction at nose and main landing gears, accelerations in the X directions, and also load factors in the vertical and longitudinal directions. Okay? So, first, simply para hindi tayo malito, we write this is A and this is in X direction. Okay? So, first, we solve the summation forces Z. Okay? Summation forces Z is equal to 0. Going up is positive. So, meron tayong R1 plus R2 minus W is equal to 0. Tama? After nun, wala na. So, we have R1 is equal to 120 pounds minus R2. Okay, that is our equation 1. Next, we want to have another equation, no? Kasi wala tayong makukuha for the two unknown. We might as well, is we need to create another equation. So, summation moment at CG is equal to 0 clockwise positive. So, lahat ng moment at CG. So, lahat lang na may perpendicular forces, mawawala yung MAX, mawawala yung weight. So, that is, so, unahin natin yung RT. So, that is 4 feet. 4 4 feet. Okay. So, 4 feet. RT. Next is the BF, which is 13 feet. So, negative 4 feet. RT, negative 13 feet. 0.3 R2. Okay. Next is R2, 14 feet. So, negative 14 feet R2. The next is positive. Positive R1, 56 feet is equal to 0. So, meron tayong value ng reverse thrust, which is 8,000 feet, no, as given kanina. So, we will get another equation ng R1, R2. Okay? So, this is 8,000 pounds. R2, no? Pwede natin pagsamahin to. So, And then, lipat natin, o kunin natin yung value ng R2 from this equation. So, we transpose this sa kabilang side ng equation and also the value of R1. So, simply, 13 times 0.3, that is 3.9, negative 3.9 minus 14, that is negative 17.9 feet R2 is equal to 8,000 times 4, that is positive 32,000 pounds minus 56 feet R1. Correct? Now, meron tayong value ng R1. We equate the equation 2. Equation 1 to equation 2. So that is negative 17.9 feet R2 equals to 32,000 pounds, negative 56 feet times 120. Ito is pounds feet pala. Okay, this is pounds feet. Pounds foot. Yan. Okay. And then pounds foot. Negative 56, 120 pounds minus the R2. Okay. So, whole method, no? This one, 56 times 120 pounds, 56 minus R2. So, 17.9 feet R2 is equal to 32,000 pounds. Feet minus 56 feet R2, positive. Negative times negative. And then, negative of 56 times 120,000. So that is 6,720,000 pounds feet. Okay? So, pwede natin itong ilipat, no, through the other side of the equation. We have negative 17.9 minus 56. So, we have 73.9 feet R2 negative is equal to, no, 67 to 0,000 minus 32,000. That is 6,688,000 negative pounds feet. Divide both sides by negative 73.9 feet. We cancel out ang negative value, the feet. So R2 is equal to divide 73. That is 9,500. 9,500.67659 pounds. That is R2. And then, ang hinahanap is vertical reactions at nose and main landing gears. So R2 and simply, no, R1. R1 is equal to 120 minus alpha A. That is 499.32341 pounds. That is your R2. Ay, R1. Next question is to find the acceleration in the x direction. Okay, get the main landing gears. So we need to get the acceleration. So this is question B. Question A. Okay, so B, to find AX, no, that is A sub X, acceleration in the X direction. We use the X force equilibrium equation. Okay, ano yung X force equilibrium? Summation forces X, no? Dito hindi natin ginamit ang summation forces X. We just use the vertical direction and the summation moment CG. So summation forces X is equal to 0, clockwise positive. We have the RT, which is 8,000 positive pounds. No, positive 8,000 pounds. Positive MAX, and then positive BF. No? So positive 0.3 times R2 is equal to 0. Okay? From that, no, makukuha na natin yung ating A sub X. Okay? So, M is from the 120 pounds. Tama? Okay? So, from the X, in X direction, we compute the summation forces or X force equilibrium equation. So, we have MAX. MAX is equal to negative 8,000 pounds minus 0.3. The value of R2 is store A and 90,500. So that is store A pounds. And then MAX is equal to negative 8,000 minus 0.3 multiplied by store A. So that is negative 35,150.20298 pounds. No? However, A sub X lang hinahanap natin and mass is equal to weight over G. Therefore, weight over G, A sub X is equal to 35,150.20298 pounds. Divide both sides or multiply both sides by G over W. Therefore, cancel out. And A sub X is equal to 35,150 divide 120. So that is 0.2929183581 G. Okay? So that is 0.2929183581 G. So ano ba yung value ng G when it comes to English? So this value, A sub X, is negative 0.2929183581 times 32.174 feet per second squared. So will result to 9.424355 feet per second squared. Okay? So final answer will be this one in terms of feet per second squared. Next is load factors in vertical and longitudinal direction. So again, load factors is in terms of G. So therefore, ito yung sagot sa C. So this is your load factor. How about naman A sub A? So dahil touchdown, no, load factor is equal to 0 kasi coming to stop yung ating aircraft. Okay? So for the next video sa part 2, we'll be discussing subpart C, structures ng FAR part 23 up to BN diagram discussion. And again, no, multiple problem solving to be discussed.